Hey guys, so this week we've been learning about properties of exponents. So far we've learned 3 properties. What we're going to do today is we're going to practice it, but we're going to put them all together. They may look very daunting at first, but if you take each property and you apply it, it's not that bad. So let's see what we've learned so far. For the first property, we know that when the base is the same and you multiply across, you add your exponents. When the base is the same and you multiply across, you add your exponents. For the second one is power to a power. So when you have an exponent taken to a higher power, you multiply them. Power to a power, we multiply. And the last one, as you see, you have multiple bases, and what you need to do is that exponent needs to go to both of those. So a to the second power, power to a power, you multiply, that's how you get the 10. Technically, the exponent on the b is a 1. So you're still going to multiply those, and that's how you get b to the 5th. So here's 4 examples, just like in the notes, that we're going to try together. We're going to use all of the different properties that we've learned and just take it piece by piece. So let's see what we have on the first one. Well, I know we have power to a power, but the other thing I really want to pay attention to is how many bases I have inside the parentheses. There's 2 different bases. There's the 3 and the d. I'm going to put a 1, the exponent of 1 on the 3, only so I remember that that is a base and that I need to multiply those. So let's simplify that first. 1 times 3 is going to give me 3. Keep your base exactly the same. 5 times 3 is going to give me 15. The base is the same. Now, same thing right here. We know the exponent is 1. I just want to put it there so I remember that when I bring it down, when the base is the same and you multiply across, you add your exponents. So I'm going to add these. So I have 3 to the 3rd power, and then d to the 16th. Now, 3 to the 3rd power, we can probably simplify that. And since we're practicing, we probably should. So 3 to the 3rd power would be 27. D to the 16th. Let's look at the second one. Same situation here. I have more than one base, so I want to make sure that I distribute almost that extra power to both of your exponents. Keep your bases the same. So 2 will be taken to the 2nd power. 3 times 2 gives me 6. So I'm going to have x to the 6th power. Bring down everything else. 2 squared is going to give me 4. Then when the base is the same and you multiply across, you add your exponents. I'm going to add those exponents right there. X to the 10th. Okay, for these last 2 examples, they might look like a little much, but again, we're just going to break it down by the steps and we'll do just fine. So looking at letter C, I noticed that this entire expression is taken to the power 6, so I should definitely address that first. I'm going to put an exponent of 1 on the 2, just so I remember again. Power to a power, we multiply. We're going to keep our bases the same. So our 2, 1 times 6 is going to give me 6. 4 times 6 is going to give me 24. And 3 times 6 is going to give me 18. Now I'm just going to bring down that first expression, and then we're going to address multiplying those together. So the next thing we'd want to do is definitely simplify 2 to the 6th. I don't know off the top of my head, so I use my calculator, and I find out it is 64. Okay, so just for the sake of space, I'm just going to make that a 64 right there. So now, let's see what we have. We have like bases because they're both a number. So let's multiply those. We have 64 times -4 gives me -256. -256. Now both of those are gone because I already multiplied those. I like to get rid of things that are very simplified. Same base, we're multiplying across, so we need to add our exponents. So m to the 2nd power, m to the 24th, you add those together and get m to the 26th. cross them off, you're done with them. Last, we have n to the 18th and n to the 3rd. When you have the same base and you multiply across, you add your exponents. You're going to have n to the 21st power. All right, just one more left. Similar situation here. I know I need to address this first. Let's put in any exponents that are missing. I only do that to remind myself that that is a base and that that 4 needs to go to that 2. You have to multiply those powers. So it's just a reminder. You don't have to necessarily show that. So when I do that, I'll have x to the 4th, y to the 4th. Remember, power to a power to multiply, so that's going to be to the 12th. That's z. Let's bring down everything else. But when I bring down these first two, I'm going to put an exponent of 1 on them because I know I'm going to be adding those exponents next. So xy, x squared, y cubed, z squared. And now we just have to look for similar bases, all right? When the base is the same, when you multiply across, you add your exponents. I know it's a lot, but you're going to remember that. Here are my like bases. We got this guy, my x's. All right, let's add our exponents. We have 4, 5, 6, 7. X to the 7th. Cross them off, they're done. Next we have our y's. There's 1. Here's 1. Here's 1. I'm always very hesitant to use red because I know in some of our classes, some students are colorblind. So sorry for the 2 colors. Okay, so we have 1 and 3, and then 4, that's going to give us y to the 8th. And that's gone, that's gone, and that's gone. The only 2 we have left are z squared and z to the 12th. When you add those together, you get z to the 14th. And we're all done. All right, guys, for this last part of the review, we're going to look at 2 word problems. A box of staples contains 10 to the 4th staples. How many staples do 10 to the 2nd power have? So I know 10 to the 4th is 10,000. I know 10 squared is going to be 100. But let's make it easy on ourselves. If we have this many in a box, and we have this many boxes, we know we need to multiply. So we have 10 to the 4th times 10 squared. And the base is the same, and you multiply across, you add your exponents. And I have 10 to the 6th power. And that's how many staples, which is, let's see here, 1,000,000 staples. All right, let's look at our next one. There are about 10 to the 23rd atoms in 1 ounce of gold. Now, that's crazy. I'm a big fan of Gold Rush. I don't know about you guys out there, but that's interesting. So in one ounce, there's 10 to the 23rd. Now, that's a huge number. There's 1,000,000 is 10 to the 6th. So that's a huge number. They want to know how many atoms are in 10 ounces of gold, 100, 1,000, 10,000, and 100,000. We're going to make this really easy on ourselves. It's similar to this. We have our starting 10 to the 23rd, and we're going to multiply. But we need to know what these exponents should be. So 10 is going to be 10 to the 1st power. 100, 10 squared, and that's going to follow that pattern. So when we add our exponents, this is going to give me 10 to the 24th. Since it's 2, I would be adding 2 there, 10 to the 25th, and so on and so forth. It's a lot of atoms. All it tells us is to complete the table, and we did. Thanks for tuning in.